This is the question we were doing yesterday. We had discussed how the figure will be formed, and we are given that the diameter of the hemispherical depression, which is carved out of this cubical box, it's equal to the edge of the cube, and both are to be represented by L. The variable L is given in the question itself, so you don't have to worry about that. Further, they are saying you have to find out the surface area of the solid formed. Determine the surface area of the remaining solid, not indicated, so we will be calculating the total surface area. How would you find out the surface area for this figure here? Remember that this is a depression here. This part has been emptied out, carved out कर लिया है या खाली है यहाँ से. तो आपके पास जो surfaces बनेंगी वो कौन कौन सी बनेंगी? From the total surface area of this cube, there is one thing which has been removed. From the top face, this circular portion has been removed, which will be the base area of the hemisphere. So a circular portion has been removed. And along with that, ये जो ऊपर flat surface आनी थी ये remove हुई है, but there is a curved surface now created. We need to count that area as well. We will be writing down this. So it's exactly the same thing we had written for the previous question. So total surface area of solid formed. That's correct. That's correct, Shreyas. Let's write down the answer. You can calculate radius. It will be L by 2. We will have total surface area of the cube minus the base area of hemisphere plus the curved surface area of the hemisphere. So the surface area of cube is given by 6 into edge square, that will be L square, minus the base area of the hemisphere, it will be pi r square, it will be pi L by 2 squared, then the curved surface area is 2 pi r square, it will be 2 times L by 2 squared. You can simplify and obtain the answer for this. Is it the answer? You can take the LCM if you want, or you can leave it as such. You can take L square common and then simplify. If you like, you can just leave your answer as such. Please check if the answer
is... Yes, ma'am, it's the answer.
Okay. Anyone who's writing, maybe you've done already.
No, ma'am.
That was a very quick answer. All right. Question number 6 here. A medicine capsule is in the shape of a cylinder with 2 hemispheres stuck to each other, stuck to its ends. The length of the entire capsule is 14 millimeters and the diameter of the capsule is 5 millimeters. Find the surface area. This one is like the first example given in your book where you're trying to explain how a solid is formed and how you will count or calculate the surface area for the solid form. So you can divide it right here. There are 2 hemispheres on the ends and in between there is a cylinder. So the middle portion will be cylindrical and the portion at the ends will be hemispheres. Hemispheres on both ends. And as you can see, this 5 millimeters will actually be the diameter for the hemisphere. And from here, you can find out the radius of the hemisphere. The total length of the capsule is 14 millimeters. For the hemispherical part, we don't need the height, but for the cylindrical part, we have to find out the height. So this 14 millimeters can be written as sum of the radii of the hemispherical portions at the 2 ends. In between will be the height of the cylinder. So 2r plus h gives you the total length of the capsule. Let me know if you follow what I have written here. The total length of the capsule can be written as the length of the middle portion, which is cylindrical. That will actually be the height of the cylinder plus the radii of the 2 hemispherical ends. That will give you the total length. From here, you will be able to find out the height of the cylinder. For the hemisphere, we only need the radius. We have the diameter as 5 mm. So the radius can be represented as r. It will be 5/2. And as you can see by observing from the figure given to you in the book, the diameter for the cylinder is same as the diameter for the hemisphere. We are representing both by the same variable. I'll be representing the radius for hemisphere and the cylinder, both by r. For the height of the cylinder, we are going to make an equation here. So from the center of this hemisphere to the boundary, this is representing the radius. And from here, from the center of the hemisphere again to the boundary, we have the radius. And in between, we have the height of the cylinder. So h plus 2r equals to 14 millimeters. From here, you can find out twice the radius will be the diameter. So h comes out to be 9 millimeters. And now you can find out the surface area of the capsule. Anyone who can answer, how will we find out the surface area of the capsule?
Area of cylinder plus area of the hemisphere.
You need to specify, we are taking the curved surface area or the total surface area.
Ma'am, total surface area.
Think.
Curved surface area.
Curved surface area.
We will only be having the curved surface areas for the three solids that we can see here. Curved surface area of two hemispheres at the ends and the curved surface area of the cylinder. 2 times 2 pi r square, then plus 2 pi r h. And before you solve, you can take factors common if you want. You will be left with this. And now you can put the values. Evaluate your answer. I hope pi is, yes, pi is 22/7. Anyone who's writing?
No, ma'am.
No, ma'am.
Yes, ma'am. Done, ma'am.
Okay. Question number 7. A tent is in the shape of a cylinder. surmounted by a conical top. Height and the diameter of the cylindrical part are 2.14 meters respectively. Then the slant height of the top, which is conical in shape, so it's given here, it's 2.8. Find the area of the canvas used for making the tent. So area of the canvas, area of the material that will be used to make the tent. We need to find out the area of all those surfaces where the canvas will be used. And they have given you a clue here. The base of the tent will not be covered with the canvas. तो जो tent बनाने के लिए canvas use होना है वो कहाँ पे use होगा? On the cylindrical part, the base which is cylindrical यहाँ पे use होगा. Then for the conical part, the top which is conical, for that also the canvas will be used. So canvas will be used on two areas: the curved surface of the conical part, the curved surface of the cylindrical part. The measurements are given to you. The diameter for the conical part, and okay, let's just mark it. This across is given as 4 meters. The vertical height is given as 2.1 meters. And it's not indicated that the conical part or the cylindrical part have different radii. So we will be assuming that the radius of the cone on the top is same as the radius of the cylinder given here. Along with that, the slant height of the conical part is 2.8 meters. So whatever is required to find out the curved surface area of these two, cone and the cylinder, is available. We have the radius and height for the cylinder. We have the radius and the slant height for the cone. Afterwards, you need to find out the cost as well. Once you have the area of the canvas, you need to find out the cost at the given rate, 500 rupees per meter square. Anyone with questions? This is a simple question. Like, इसमें कुछ भी ज़्यादा calculate नहीं करना. Diameter है, height है, slant height है. Apply the formula, find the area, and then find the cost. Thank you, Sahaj, for saying that you'll be doing this on your own. I would just help you write this down. So there is a conical part and there is a cylindrical part. The diameter for both is same. So radius will also be same. And then the slant height for the cone is 2.8 meters and the height of the cone cylindrical part is 2.1 meters. We have to find out the area of canvas. And then afterwards, you need to find out the cost of canvas.
Ma'am, the answer for area of canvas needed is 44 meters square.
Okay. So 500 into 44.
Ma'am, 22,000.
All right. If anyone's writing,
No, ma'am.
No, ma'am.
question number 8. From a solid cylinder whose height is 2.4 meters and diameter is 1.4 meters, a conical cavity of the same height and same diameter is hollowed out. Find the total surface area of the remaining solid to the nearest centimeters. So question 8th and question 9th are quite similar. So there is a cylinder for which the diameter is 1.5 centimeters. The height is 2.4 centimeters. There is a depression cut out, a conical cavity of the same height and the same radius. So the vertical height for the conical part is same as the height for the cylindrical part. Even the diameter is the same for the conical part. So you have to find out, once this cone has been carved out, what's the area of the remaining solid. Area of the remaining solid, the answer is to be calculated to the nearest centimeters. Maybe you will have answer in decimal value. So you need to write the answer to the closest centimeter square as a whole number. So total surface area of this solid will be given by the curved surface area of the cylinder plus the curved surface area of the cone plus the base area of your cylinder. And why I'm taking the base area of the cylinder? Because it's indicated that the cylinder is solid. Solid है तो उसका base होगा, base exist करेगा. That's why. अगर ये hollow होता और उसके अंदर एक conical cavity हम fit करते हैं तो उस केस में फिर base area नहीं आएगा. Or you could also write like this: total surface area of the cylindrical part minus the base area of cone plus CSA of cone. This is another way. Both are equivalent. I'm going with this one. Just by looking at कि मेरे solid shape में कौन कौन सी surfaces हैं. एक cylinder की outer curved surface है, cone की अंदर वाली curved surface है और cylinder का base है. So these are the three surfaces for which I want to find out the area. Is there anything else you would like to calculate first before we calculate the areas? We are going to calculate the curved surface area of the cone. For that, we require the the slant height. So do calculate that first. So this approximately, I think, will come out to be 2.5. 24 square and 7 square, 2.5 centimeters. Now you can find out
Yes, ma'am.
the total surface area of the solid. This will be CSA of the cylinder plus CSA for the cone plus base area of cylinder. So answer is 17.6 centimeters. For this, if you have done, please check. This
1 minute, ma'am.
Okay, take your time.
Yes, ma'am, it's correct.
Since we are given to find out the area in the nearest centimeter square, तो closest जो whole number बनता है आपको वो आंसर देना है. 17.6 round off करके क्या बन जाएगा? 18. So the answer would be 18 centimeter square. If the value is at half or more, you round up to the next value. If the value is less than half, you round off to the previous whole number. So 17.6 will be rounded off as 18 centimeter square. Last question. A wooden article was made by scooping out hemispheres from each end of a solid cylinder, as shown in this figure over here. The height of the cylinder is 10 centimeters and the base radius is 3.5. So the radius of the base, you can just mark. This is 3.5 centimeters. This will also act as the radius for the hemispherical parts. You have to find out the total surface area of this article. So how would you find out? What do you think will be the total surface area for this article? There will be this curved surface of the cylinder, which is outside the outer surface, the curved surface of the cylinder. Along with that, there are now two surfaces. Otherwise, पहले जो हमारा cylinder था, solid था, ऊपर flat surface थी, नीचे yes, that's correct, Tarannum. ऊपर फ्लैट सर्फेस थी, नीचे फ्लैट सर्फेस थी, सर्कल्स थे. नाउ आफ्टर स्कूपिंग आउट दोज हेमिस्फेयर्स, वो सर्कुलर बेसिस जो थे वो नहीं रहे, उनकी जगह पे कर्व्ड सरफेस क्रिएट हो गई है और वो कर्व्ड सरफेस इज फॉर द हेमिस्फेयर्स एट ईच एंड. So we will be calculating the surface area by curved surface area of the cylinder plus the curved surface area for the two hemispheres. What happened, Vansh?
मैम गलती से हो गया.
Okay. Please check.
Ma'am, it's 374.
Okay, then I think I've missed something. We have 4 pi r square. Isn't this correct? Please check. Okay, this is 17. The last value is 17. It's 374.
Yes, ma'am.
Ma'am.
Done?
Yes, ma'am.
Okay. Compared to this exercise, the next one is quite easier. In case of surface areas, you had to think of which surfaces you need to calculate the area for, whereas in case of volume, it will be simpler because if two solids are combined, their volumes are also combined. Exercise 13.2, it's on page 247. Use pi as 22 by 7 unless stated otherwise. First question, a solid is in the shape of a cone standing on a hemisphere with both their radii being equal to 1 centimeters and the height of the cone is equal to the radius. So height of the cone is equal to the radius, which is equal to 1 centimeters. So the height will also be 1 centimeters. You have to find out the volume of the solid in terms of pi. Pi's value will not be substituted. So we can just draw a rough figure for this and then calculate the area. On the base, you will have a hemisphere and on the top, there will be a cone. And their radii is 1 centimeters. And for the conical part, the vertical height is 1 centimeters. Please use the formula carefully. Volume of the cone, 1 by 3 pi r square h, and the volume of a hemisphere is 2/3 of pi r cube. Pi not to be replaced. One third pi plus 2/3 of pi. The answer is pi centimeter cube.
Yes, ma'am.
Second question. Rachel, an engineering student, was asked to make a model shaped like a cylinder with two cones attached to its ends. They are attached by a thin aluminum sheet. The diameter of the model is 3 centimeters. So this will be the diameter for both the shapes, the cylindrical part and the conical part. Length is 12 centimeters. This is the length of the whole model. If each cone has height 2 centimeters, find the volume of the air contained in the model. that the student has made, assuming that the outer and inner dimensions of the model to be nearly the same. So हम thickness ignore कर रहे हैं. अगर thickness होती तो volume reduce हो जाना था. Because of that thickness, फिर हमें inner dimensions चाहिए थी. So यहाँ पे उन्होंने बोल दिया कि हमें consider करने की जरूरत नहीं है. You can draw it either horizontally. You can draw a cylinder and then draw cones on the two ends. You have been given that the diameters for these is 3 centimeters for the cone as well as for the cylinder. The vertical height for the cone is 2 centimeters. Whereas the total length of the model is 12 centimeters. The middle portion will be forming the height for the cylindrical part. Can you find out the height using this? Now, to find out the volume of the air contained inside this model, what shall we do? All the solids that you see here, the volumes need to be added. So the volume of the model, sorry, the volume of air in this model will be volume of the two cones plus
the volume of the cylinder.
cylinder. That's correct. So let's draw it and then write down the answer. So it's not necessary the way I've drawn horizontally the model. You can draw it vertically as well if that seems comfortable or convenient to you. All right. I would like to change a thing here. If you can realize, I am using height of the cone and height of the cylinder, and these are different. So I'm going to use a different variable here. I'm going to represent the height of the cylinder with capital H. So from the observation of this model, this is what I get. And the height of the cylinder comes out to be 8 centimeters. So please mark this. I'm using a different variable now. Height of the cone with small h, height of the cylinder with capital H. And now you can find out the volume of the solid or volume of air in the model. Yes, you can take it as H1 and H2 also. Let's take pi r square common. And then put the values. Pi is 22 by 7. The radius is 3 by 2. 2 by thirds the height of the cone and the height of the cylinder. So this will be 11 into 9 by 77. 4 by 3 plus 8. 66 cubic centimeters. So this will be 24 plus 4, 28 by 3. Are you sure? Please check.
Ma'am, 132 centimeter cube.
Let me just see. 12,
Ma'am,
yes,
it's six-
132. It's 132.
Yes, ma'am.
Has anyone else calculated? Okay, why is the answer not matching? Did I miss something?
मैम बुक के पीछे मैम 66 ही मैम आंसर दिया हुआ है.
That's what I am wondering. Why is the answer 66 centimeter cube?
Ma'am, it might be wrong. Ma'am, like in the assignment also.
मैम आप
of-
2 मिस कर गए.
Could you tell
Yes,
me
ma'am. Yes, ma'am.
where did I miss the 2?
मैम डिनोमिनेटर से 2 लास्ट सेकंड स्टेप.
Over here? Yes.
Yes,
Yes,
ma'am.
ma'am.
And there were
Right.
2 twos.
Okay. So now the answer will be 66 centimeter cube. All right. Thank you, Punya. Okay. Is it done?
Yes, ma'am.
Yes, ma'am.
Question number 3. A gulab jamun contains a sugar syrup up to about 30% of its volume. It's an important question. Find approximately how much syrup would you find in 45 gulab jamuns, each shaped like a cylinder with 2 hemispherical ends with length 5 centimeters and diameter 2.8 centimeters. This is the gulab jamun that